So we've looked at expanding logarithms. Now we're going to use those same properties and condense logarithms. You'll see that the properties that we have here on the screen are the same as we used before. I've just written them in the other order because now we're going to be going from adding two logarithms to multiplying in a single logarithm, or subtracting two logarithms to division in the same logarithm. And so I've just kind of rewritten those properties, but they really are the same as we looked at before. The first two examples that we're going to go through are two that you will see there on your note sheet, so make sure that you are getting them down. If we start with something such as 4 times the log base 4 of m plus 3 times the log of base 4 times n minus the log base 4 of p. Now, again, I want to point out that these base numbers don't really matter as far as our property goes, but make sure that if you are putting things together, that those bases have to all be the same. These properties only work if our bases are all the same. So then we're going to go through kind of a step-by-step process to condense these. So instead of having this number out in front, now we're going to remember that that means it should be kind of our exponent. So I can rewrite this as log base 4 of m to the 4th. I'm going to do the same thing for that next one and rewrite it as log base 4 of n cubed minus log base 4 of p. Now I need to get rid of those addition. And so what I'm going to do is put them together under one logarithm as multiplication. So this will become m to the 4th times n cubed. I haven't really touched this subtraction one on the end, so I'm going to leave it like that. Now, if I want to get rid of this subtraction, I can go one step further, put it all together in one logarithm, and divide by that p. Now remember that division is important as far as where things are, just like subtraction, the order matters. Whatever we are subtracting has to go there in your denominator. So just pay careful attention to kind of where it's going as you put it together. Let's look at that next example. Your next example on that note sheet is 3 times the natural log of 2 minus 2 times the natural log of 5. Remember that this natural log just means that it's log base e. So these properties still work. We don't have to change it into log base e. The natural log is still a logarithm, so it will still follow those types of rules. So I'm going to just take the first step and go 2 cubed minus the natural log of 5 squared. Now remember, as I subtract that, I'm going to get the natural log of 2 cubed divided by 5 squared. Now really, if we want to condense this all the way, we're going to go ahead and find what those numbers are. So 2 cubed is 8. 5 squared is 25. So here's our condensed version of what we started with. Now, really, if you feel like you've got the hang of it, you could stop the video here and you should be in a good spot having a couple of examples. I want to continue to go through probably about 4 more example problems just so that you keep seeing it if you need to see some more examples. The next one we're going to look at is log of 3 minus log of 8. I want you to take a minute, pause the video, and see if you can figure out how to write this one. Okay, so if it's subtraction and I want to put it together in one logarithm, I'm going to change it to division. 3/8 we're going to leave as a fraction. We can't simplify it at all. We don't want to put it into a decimal because it will change the value a little bit. So just leave it as 3/8, but that's as simplified as it could go. What about log of 2 plus the log of 11 plus the log of 7? These are all addition, which means I can put them together in the same logarithm by multiplying them. And when I go one step further and really multiply these, we're going to end up with, let's see, I do the 2 times 7 will be 14 times 11. So we're going to end up with the log of 154. As condensed as possible, we're down to just a log and a number. We started with this. Okay, here's another example. What if we had 4 times the log of 3 minus 4 times the log of 8, and we want to condense it? Well, I'm going to start by, there's really two ways we could do this one. I'm going to show you both ways just so you kind of see it. The first one I could do is I could get those exponents out, right? So it would be log of 3 to the 4th minus log of 8 to the 4th. I can put together that subtraction by putting it together in 1 with division. And then I could go ahead and find those numbers. Let's see, 3 to the 4th. This is going to take some mental math here. 3 is 81. 8 to the 4th, I got to really think about that. Let's see, it's 64 times 8. And then we still need it times 8 one more time. Oof. 4,096. Now the question is, can I simplify this at all? We'll just kind of leave it hanging at this for now. Now the other thing that we could do here is we could say, well, this is 4 times the log of 3 minus the log of 8. See, I could take out kind of that common multiple, which would then become the log of 3 divided by 8. And then if we want to get this inside our logarithm, we would have 3 to the 8th to the 4th power. Now notice when we take a fraction to a power, we're going to do it that power by each part. And notice that this is the same step as this right here. So I show you those two ways because as you're condensing, as long as you get every step condensed following these properties, your order won't always matter. Make sure that if you're subtracting something, it's always the number subtracted is always in the denominator, right? Things like that. But as long as you're following the rules of order of operation and these properties of logarithms, your individual order of steps won't matter. Let's take a look at one more example. And here we're going to take a look at 6 times the log base 3 of u plus 6 times the log base 3 of v. I want you to go ahead and pause the video and give this one a try. Okay, so you may have something that looks like this, right? You may have taken some different steps to get there, but this is what it should look like there at the end.